I want to start off by saying you're really lucky to have me here. I almost canceled. Last minute, while I was at the airport this morning, I flew in from Nashville this morning. I'm actually from Edmonton, Alberta, and I was on another trip. While I was boarding the plane, I got a notice from our CEO, call off all travel. If you're doing anything else. And I was like walking down the jet bridge while reading that. So this is my last travel for a while, so you're not going to see me very often. But today I'm glad I'm here. I'm going to talk about declarative caching with Postgres and Redis. So a little bit about myself. That's me if you don't recognize me. Change glasses. They want us to put these kind of business card things at the beginning of our presentations with some information on it. I've been using Redis for a long time. I've been a developer for about 21 years, and a lot of that time has been spent working with databases, a whole variety of different databases. I've been using Redis for about 8 years, and Postgres is something I've touched for a long time, but it's been like a focus area for me. But I've been working with Redis for a long time, and Redis is one of those databases you use in concert with other databases. So we'll talk a little bit about just some general stuff today, how it relates to Redis and how it relates to Postgres. This is specifically Postgres talk because this is a tool that only exists for Redis and Postgres together. Here's some generic slides about Redis. Who here knows what Redis is? Oh, yes, thank you. Who here has used Redis for more than a couple years? Okay, a few people. A couple other questions I have. Who here writes code for a living? So you're actually like a software developer or a software engineer? Okay. DBAs, anybody in here? Good number, okay. Operations people? Okay, like weirdly equal mix, so that's great. So when we talk about Redis, it's an open source in-memory database for those, most of you know, but it's high performance and not good for operations, analytics, and hybrid use cases. That's what we tell people. It's just kind of a general purpose tool though for doing really fast data operations, primarily in memory. So it stands for Remote Dictionary Server, or that's actually what we were originally told, and Redis turned 10 years old a few years ago, 2009. Last year it was 10 years. But we found out, Salvatore, the guy who created it, he basically told me that, well, we wanted a 5-letter domain name, and Redis was available. So he got Redis.io. That's true, and like, I was like, I've been lying for so long. I've been working at Redis Labs for a few years now. It's open source. You can go to Redis.io. It's a really great website. It's very like no nonsense, no marketing BS. It's just Redis.io, right? Like it's got documentation, it's got best practices. That's it. On the GitHub page, there is the full source of Redis, and I encourage everybody. It's written in C, which is kind of interesting. I spent a lot of my career trying to avoid projects written in C, and Redis kind of taught me that C was able to be done in a pretty nice way. So Redis Enterprise is one of the things that we sell. It's an enterprise-grade version of Redis, but it has a lot of enhancements on top of it. So basically, it enables people to take and make running it at large scales really easy, and kind of the enterprise features that you want with it really makes it approachable. It makes it not like a thing where you have to understand all the internals of Redis to run it at massive scales. And then it adds on top of that things like modules and something we'll get to at the end of the presentation as far as geo-distribution and a couple other things. But it does have a lot of things to it. In fact, there's Redis Enterprise. It's like an installable software, a licensed software, but there is a Redis Enterprise Cloud that you can get a free instance of for life. It's not very big, but that's on redislabs.com. So I want to talk a little bit about what happens when you start building something, right? You have a database connected to a server, and this is how most things start, right? Very simple. Maybe a single server and a single database. Maybe they're even on the same machine. But at some point, something comes along, and you start making more and more connections to the database, or you start running more and more queries on the database, and it just starts to get really busy, and the database is starting to somehow struggle, right? And that's a pretty easy thing. You think, well, okay, what am I going to do here? And the thing that most people think about is a cache. And a cache looks something like this. So you have something that's taking, maybe in some ways sitting in the middle, maybe it's most often being used for reads, to accelerate reads. So you're writing to your database and then you're reading it from something like a cache. It doesn't have to be Redis, but that's what we're going to use in this because that's where I work and they pay me. But this is how you make this solution work. And it really does help a lot. It's kind of one of those things that's like, oh yeah, you just put a faster database in the middle that doesn't do as much and you don't have to worry about things. It's cache, basic idea. Now, it's designed to save the day as far as performance is concerned. We take a look at this. Let's take this situation. Let's say that you have, something that's running, 100 times in a second, right? So 100 times in a minute. So every 60 seconds. You have to do one repopulation time during that. You'd repopulate your cache once, and then you pull from your cache maybe 99 times. So when you start averaging those numbers out, your overall performance gets really, really nice. Of course, I'm going to go a lot deeper than this. It's just kind of setting the stage. You can also think about it as some way to save load from being a really problematic thing. So, if you have 10,000 queries per second, and you have a situation where you've got like 95% CPU utilization, what do, right? You can put a cache in the middle, or you could scale out your database. Usually a cache in the middle is just a lot easier. In that case, you're doing some sort of ratio. You might have a situation where you have, 1/10 of your previous queries writing to your actual database, and then 9/10 are going to the cache, right? So in that way, you don't have to spend all the extra money because your CPU on your database is now much, much less than it was before, right? So this is all probably pretty easy to understand. But what happens is everybody thinks, well, if a little cache is good, a lot of cache is great, right? And that's actually not always the case. So this is a situation here. You have, your database is running in a millisecond. It's returning the query in a millisecond, right? And you already have a CPU utilization of 2%. I can't help you, right? Like that's something that you're already getting in a situation where whatever database you're using is already performing really well. If you actually add caching to it, it may actually have a negative effect. So let's take a look at that. When you have this negative effect, effectively when you have a cache in something, you're effectively adding in two hops. You have a repopulation hop between your database and the application or the cache itself in some sort of mechanism depending on what type of cache you're using, and then you have the hop from the database. So sometimes you'll have situations where that'll actually happen frequent enough that you're causing repopulations all the time and you're not improving the speed, but you're actually making it slower because you're adding latency into the operation, right? So that's where it can go wrong. And then you can have situations where you have things that are inappropriate to cache. Now think about this. Let's say that you had a situation where you had a user system and you were caching the user's password, their authentication some way, right? So it's hashed and all of that sort of good stuff, so I'm not telling you to actually just write plain text into any data storage method. You're caching it for about 60 seconds, and that's where you're retrieving it from. Someone goes and changes their password, and then they store that in the database, but for some reason it doesn't get repopulated into the cache. You go to log in, it still thinks the password is the old password, and you get the worst feeling in the world. And I think we've all been through this cycle of, I've just changed my password, why are you telling me it's wrong? Probably not that, it's a different reason, but this is just an example. There's lots of things that you don't want to cache because it would be inappropriate to cache the data that's on the other side of it. So you need to be able to control things. You look at things that are already running fast enough, you look at things that are already, are not really something you'd want to cache. So, there's all sorts of reasons that you would not want to do this. Another one that you want to look at is this situation. Let's say that you have something that you're doing a lot of queries that look very, very similar for whatever reason. In this case, you're polluting your cache with a lot of different similar queries, and you're filling up the entire cache space you have allocated. And at that point, you don't have any reasonable way of thinking about what should be evicted and what should not be evicted, right? So you want to intelligently, or you want to have some sort of mechanism to evict in an appropriate way. So if you just have everything that is all this kind of nonsense, well, that's maybe not very valuable either. So in essence, what you really want to think about is, how do I write an application and use a database and use a cache and do it in a way that I can figure out and quickly be able to make those modifications in a way that I can add something in without completely rewriting all the code. So let's look at this for just a second. Look at the exact kind of code that you go through. Just some pseudocode. You know, you're doing the most basic things in the world, things I could fit on a slide in PowerPoint, to be frank. But I'm doing a select statement, very easy. I've got that in a variable here. This is all nonsense language. It doesn't really associate to anything particularly. You're going to take the query and somehow hash that value, or put it in a way that your database is not going to choke it, or your cache is not going to choke on it, right? So you're going to put it through a quick hash function. Maybe you'll just do something as simple as like encoding it in JSON, right? There'll be something simple where you'll take that very simple thing and turning it into a smaller and more digestible key that your hash will use, or your cache will use. In this case, you'll say, does it exist in my cache? If it doesn't, then we're going to grab the data from the cache, and we're going to store that in a local variable. We'll take that local variable and we will put that into your cache. So you're taking the key, and Redis is a key value store, so for the most part, there's other things that are there to it, but we're taking the key that we generated from the query, and then we're taking the data and we're setting it there. And then we're setting a time to live on it. Something, this is kind of the intelligence that I was talking about, just something simple to say, after a certain amount of time, let's just get rid of it, right? We don't care about it any longer and we can let go of it. And then you're going to send the request back to the server, and you're going to actually get the data from the Redis key very often. So you can maintain this kind of thing. If you need to repopulate, it's there. If you don't, you don't. And that's kind of the general thing that people do. One way or the other, this is kind of what these looks like. It's not perfect, but this is the way you'll typically see stuff over and over and over again in code. So as we were talking about, sometimes you don't want to cache everything. If you could cache everything, you just do it at the level of like your database library, your connection library, that you're connecting to Postgres or connecting to MySQL or whatever. So you probably want some way to like control that. Well, most people do it in a really kind of naive way. They will actually, whoops, going too fast. So what they'll do is they'll go and they'll just comment things out, right? This is not really an ideal solution, but this is something you see typically. They'll start commenting things out, and instead they'll move some things around and say, okay, I don't need this anymore. And that causes a lot of problems. And let's evaluate what they are. My preview here, that's kind of a yucky solution to this. Well, how do you solve it in a more reliable way, in a way that makes more sense as far as software development? So what are the problems? Why do I say that? One, from a general standpoint, just doing this few-step process has a lot of boilerplate in your code. You're going to actually make the amount of code quite large, because you're going to have, I think we had like 6 or 7 lines here just to do a caching routine. And you're going to put this all over your code. If you start commenting things out, I personally am of the camp that comments are actually for commenting, not controlling what is actually compiled or run on the runtime. So commenting out things is maybe not a good practice in general. It leaves a surface area for subtle bugs to develop and take hold. You're coupling everything together, so you have your data, your cache, and your source code that all kind of are now intertwined in a way that maybe is not very easy to make changes. And when you start looking at the real-world implications versus my simplified, pseudocode, it gets even worse. So we have our 6 useless lines here after we've commented this out. They have a tendency to be sticky. And I think if we will all review the code bases we have right now, you'll see a lot of commented out code, right? And that commented out code may mean something to someone, but it won't mean something to everyone, especially as you get into junior staff, people who are on the team not so long. They're like, why is this code still in here? Does it have meaning? Is it something we should be looking forward to putting back in, or is it just something that somebody didn't bother to take out? Yeah, it's a lot of things. Now, when we talk about weird surface areas for bugs here, do you spot the error in this code? It's pretty similar to the one we saw before, but basically what's happening, can you see my little pointer here? What you have here is you just did a couple things wrong. So we're doing, instead of the query and running the database query, we're running it against the key that we generated. So you're going to get these weird bugs that you're going to have that can be hard to reason about sometimes. So just a very simple problem to make. And this is a real problem. I was actually kind of writing some code for this to kind of demonstrate some of these things. And I actually did this. I was like, why am I getting an error back from Postgres? You can see here, that should be query instead of key. Another one here. This is another subtle bug. Effectively what we're doing here, we've commented out key gets down here, so it would be an undefined or some sort of, maybe even some sort of exception that it's not there, depending on what you're looking at, right? So you have these situations where you're creating these situations of, yeah, I've just commented some stuff out and I was quickly doing it, trying to understand, is it better to have something cached or not have something cached? In effort of doing that, you're creating more problems, right? So it's just not a good practice as far as writing code. Here's the solution here, you know. We're doing this, we're not actually running the key. So this is even more subtle of a bug, right? In this one, the key would be undefined, but we're checking Redis, but we're not actually running the query, so maybe we'll never even populate it, depending on how the language interprets it, right? So you get into the talk about type coupling. Redis right now is, we have Redis 6 will be coming out probably end of May. Redis 5 is the version we have right now. It actually says it on my shirt. But Redis 6 is bringing a new protocol. So we have the RESP protocol, version 3, coming out with Redis 6. And it's going to change a lot of the client libraries. So client libraries are one of those things that are not evergreen. They end up changing pretty frequently. And so when you look at this, you want to make sure that you are actually able to make those changes in a pretty easy way. So odds are you'll probably have some sort of changes to the ways things are articulated. In fact, in Redis 6, they're changing, instead of each one being its own method off of a particular object, it'll be, you're actually passing them in as arguments instead. That's not the focus of this talk, but these are the sort of things that do happen. And then let's say that you go in and you want to, change how your database is making the query. Maybe you change the client library or something like that. So you created this type coupling. Now imagine in a given application, this is just one simple thing, but if you have places where you're making hundreds of database calls across a very large code base, you're going to have a lot of changing around. You're not abstracting this very much. Finally, when we get into actually doing something in some way that's more useful, you start having to deal with things like error handling and asynchronous code and all sorts of things like that. So for example, in Node.js, which is one of the tools we'll be using, you usually have callbacks, and those callbacks you need to handle errors on. It gets really messy. So you can have situations here where you're using callbacks, or maybe you're using the promise system or async await or something along those lines. Either way, you're going to have to account for failures in Redis and failures in your database. And you're going to end up with a bunch of lines just to do something pretty simple. And you were trying to solve a simple problem and make things faster. So there's lots of problems here. So also, what happens when the cache isn't there? How are you falling back if the cache falls down, right? It's another thing you have to account for. So there's all these issues that you constantly have to account for when you're doing this. And so everybody says, okay, well, how do you fix it, right? It's not necessarily a fix that comes from a specific tool to use. That's part of it, but it's more about thinking about things differently. So imperative versus declarative. How many people know those definitions pretty well? A few people? Yeah. It's one of the things you heard a lot, but you maybe not have thought deeply about it. Imperative is what and how, right? And you've had the exercise before where you've seen a kid and you've said, how to make a peanut butter jelly sandwich or how to tie your shoes, right? And they'll just say, they'll do something very easy, but when you actually break it down to the number of steps, it becomes like a whole page of handwritten things. So in that case, that's an imperative way of approaching how to tie your shoes. Now, declarative, on the other hand, that is what, but not how. So you're just saying, tie your shoes, right? Instead of take each lace in each hand and move it around. You know, make me a peanut butter and jelly sandwich versus take 2 pieces of bread and smear peanut butter and jelly on them. So when you look at imperative things, you have a lot of logic statements, you have loops, you have things like recipes. When in your real life you are using recipes to make food, that is an imperative way of getting food, right? On the other hand, declarative, you have things like SQL, you have things like Redis, and you have things like HTML. And these are all declarative languages. You don't know really what's going on in a select statement. No, a lot of people do, but not everybody does. And the whole idea is that you don't have to know what's going on in these particular things. In Redis, you don't know what happens when you set a TTL on something. In HTML, you don't need to know what happens when you create a button. You just say, make me a button, and it does it. If we were to compare it to the real life, if recipes are imperative, a drive-through window is declarative, right? Give me a cheeseburger. So how do we then move this conversation from drive-through windows into caching? So when we look at imperative, we have our pseudocode we had before, right? And worse yet, we have our pseudocode with like all the logic that handles errors and handles caches not being there and handles all the different things. And you start realizing that there's a lot of things in this that you need to account for. So really what imperative and declarative are is really just a handshake of abstraction, right? Anytime you're having anything declarative, there is an abstraction level below it. So it really does kind of take a lot of the things that we were showing before, the boilerplate and all the moving things back and forth. When you start thinking about it from a declarative standpoint, you're avoiding many of these problems. So, SQL is declarative. Whoops, wrong way. SQL is declarative, and the idea here is integrating the caching control within the query itself. Okay? Now, this is not my idea. Gages, who wrote the SlowNet client in Node.js, I don't know if you know him or not, brilliant guy. It's a really modern client for Postgres. So I do want to give him credit for this original thing. I ended up writing the Redis implementation of this idea he had for interceptors, which are basically like middleware that you write at the application level for queries. So you could go in and modify a query at the application level through an interceptor, or get information out of it and do an action. So I wrote that, and it's available on GitHub. I'll show you at the end if you want to take a picture of the links, and I'll have a GitHub on everything. It has all this information on it. I read this article. He posted it on Dev2 in November of last year, and I said, finally. Now, in my job at Redis, I talk a lot about all the things Redis can do, and I'm frankly so bored about talking about Redis. This is the first time I was talking about caching in Redis. It's the first time I was like, oh my gosh, this is something I can talk to people about that isn't just, yeah, shove something into a database so you don't, set your database on fire. So let's take a look at what he outlined and then how it works when you actually get into Redis. So this is our code that we had before, many lines. We want to kind of toggle on and off that caching. We're putting in slashes and asterisks and doing all sorts of things that terrible to our code. Well, that's what you have when you do it declaratively. Let's break this down. So if you see this here, and we'll get into it a little bit more, but this is the operative piece, this SQL comment and then cache TTL60. So here we have, in this we have, in SlowNet they have this concept of a tag, which is a specific thing in Node.js 6, but basically it's a way to especially handle a string. We have our SQL comment that has the information embedded into it. So this just says cache it for a time to live of 60 seconds. Then we have our standard SQL query, right? What happens on the inside is Slonik will actually say, okay, I've got this, pass it to any interceptors that you have put in to your client library. You specify that when you create the client, when you instantiate Slonik. In this case, you would specify the little node module that I have. When you fill the cache, when you have this in here, when it says, hey, that's not in Redis, it will actually do set ex, so set with expiration. This is an all-in-one command that's a little bit obscure. You have a prefix which you set at instantiation. Then you have a hashing function. Built in, it actually doesn't use a hashing function, it uses a JSON encode. And then you have our query. 60 is the amount of time that it knows that from actually the interceptor itself. Whoops. And then the results are passed in to it. So the table results that you got back or the values that you got back from it. When you're fetching it, it just does a get with basically the same first argument to it. And it ends up being the actual thing that connects Redis to Slonik and AKA on to Postgres ends up being about 25 lines of code. Not much, really. Not much more than a single time that you would do it inside your own code. So it actually makes things much easier to develop and much cleaner. If you take a look at this, one thing that did trip me up with it, and I talked to Gage about this back and forth on GitHub, the one thing that's weird about it is you're caching for 70 seconds or 60 seconds, there'll be two separate caches, which I thought was weird, but I can accept it. That's kind of an argument that you could have. So that means that if you have something that's cached for a little bit longer time, you can have that being slightly different than the code. In my mind, I would just say, okay, I just want to cache that table. But that's something that was counterintuitive to me when I started understanding how this could work in Postgres and Slonik. So, everybody with me so far? Okay. It's not a terribly hard concept, but we're going to do a small demo of this. I have a load generator that is basically taking a Postgres table and inserting rows into that table. The table has 4 columns. It's got a user ID, which is an auto increment column. It's got a username, which is there's a library that generates fake usernames. So it's just putting random data in effectively. Same thing with email, random data as well. And the created at is a timestamp. Pretty simple table, not that hard to reason about. So I'm doing it 20 times a second. The created at and user ID, that's handled by Postgres. I don't need to do anything there. Then we take a look at what's going on. So this is not anything magical. This is just inserting things. When we look at the query cache and what we're actually doing that's more interesting, we're doing kind of a hard-ish query, a query that you would never really want anybody to run because it's got regex in it, right? So it is definitely going to be a terrible query the more rows you have in your table. We're getting a count, and then we're going to do this kind of crazy thing, all the emails that end in yahoo.com or gmail.com. And we're going to cache it for 10 seconds. So this is the query that's going into it. Now, like I said, we're going to be constantly running the load generator. Let's take a look at this actually. Let's kind of go from here. I never know what's going to display on what screen. Okay, so I've got pgadmin up here. And let's see here. Count rows, we have 1,600 rows. You can't see it, but it says 1,600 rows at this point. So not small, not 10 rows, which if you were in the last session where they're talking about worst practices, he talks about like everything being tested on 10 rows, which I was like, I can't come in today and talk about 10 rows. But it's pretty straightforward. Now, let's go ahead and start up down here. We are populating this, so this should just go ahead and every 50 milliseconds it's putting in a random value, right? So it's running constantly. Now, currently where I have it right now, I don't have any caching turned on. So Postgres is just running that query, and it's responding in, 10 milliseconds. And we'll say when you first started it, my benchmarking is not perfect because there is a connection delay, and it doesn't take that into account. So it will stabilize out, and then it should start going back up. So I think you can see that. It went up and then down, and then it's going up because I'm adding more and more items to it. And you can see every single row is changing the count, right? So we've run it 540 times. Okay, so 11 milliseconds, but getting worse on average. So if I go, and I'm going to stop this, and then I'm going to switch over to this, which is probably not legible at all. How's this look? Can you guys see? It's washed out, right? I don't know if I can do anything about that, unfortunately. But I will show you what I'm doing. So I'm going to add in here, it says cache TTL10, that's a comment. But I'm going to actually add it into the query itself. So I'll just copy or cut that out and put this in here. So this is now in when I'm running against Postgres. I'm going to save this. And now I'm going to run it. And if the demo gods are with me, we'll see that the response time is cut more than in half, right? By just changing about 7 characters at the end of my my query itself. So it becomes really easy. Now we're under 3 milliseconds. It should stabilize probably down to about 299 or so if I know my system. This is all running local hosts, so it's kind of made up anyway. But real world figures would be different. But you can see here, the one thing I want to point out, if you take a look here, the count is not going up every single time. Every 10 seconds it should change. So we're at 1641, now we're at, 2641, now we're at 2744. So we've just cached it for a while, right? And this becomes very easy. All I did was change that very small piece. And it could run for as long as you want to, right? And this is something that you can show and do, and you're not going to really cause a lot of distraction in your code. So stop that, and then we'll get back to the presentation. Just a couple more slides. Okay, you've seen all that. Now, the limits on this are there, and I want to be completely upfront with you about it. This is not a panacea. It is not a magical solution. It will help you out, and it can make you solve a problem, though it's limited. The one thing is, this is what you call a read-through cache, right? So you're always reading through the cache. There are other different things for different types of caching. You have cache aside, write through, write behind. They all have their own uses. This is a pretty naive version of a cache, but it is effective, right? When you get into other things, when you have, like for example, write behind, that's a more exotic type where you're actually writing to the cache and then it writes behind to SQL. Some really cool patterns can be there, but this is not that. You would never be able to make this pattern for those. So it's read through cache only. Redis has this concept of data types. So Redis is not just a key value or a key blob storage, it's a key data structure storage. So you can have things like linked lists and hash maps and geospatial things and all sorts of stuff. And you can even have search engines and like time series data and all this other stuff that's really specialized. But I'm really underutilizing Redis here because I'm just storing blobs in it. Right? So when stuff's written in Redis here, it's just bytes. We don't really care. We're just writing those bytes very fast. You do have serialization, deserialization overhead. On that note, if you're pulling in a table that has 100,000 rows, this is not going to be very effective because you're going to have to deserialize that 100,000 rows on each side. So in my case, I was getting a count out, which is kind of the best case scenario to be completely transparent. That's 4 or 5 bytes. It is also sensitive to that similar queries problem. If you have queries that are going over and over and over again, you can start filling up your cache with similar queries. It is sensitive to that. And the cache GTL differences, which I talked about with 60 and 70 were different ones. You could also kind of pollute your cache in a way that you weren't anticipating by having multiple caching values. This is only something that you can use today with Node.js and Postgres. but it's a pretty interesting pattern that we're kind of pursuing, so maybe it'll show up in other languages and other databases as well. And if you're using ORMs, which ORMs are controversial, this would not help you because your ORM would have to do it. There is a framework for Node.js called Nest.js, and it does something kind of sort of similar that has a preprocessor for its actual Node.js code, and then it ends up kind of inserting the caching boilerplate over and over again. So it kind of does it, but it, I think, goes about it in a weird way. So yeah, if you're using an ORM, there's many of them out there. This is not going to help you a whole heck of a lot. Now, I want to talk about one other thing, since we do have time, about geo-local caching. Now, geo-local, when I'm talking about this, is to achieve lower latencies by having multiple different places that you're storing your data, right? So I live in Canada. If I'm hitting a server that's located in AWS region down here, it's rather slow, right? Or I worked for, I was on the East Coast, and I worked for a company in Tokyo, and SSHing was so maddeningly hard. It was like hit a button and then have a coffee, and the character would show up. Articulate that a little bit better. The best case scenario when you're talking about coast to coast in the US is the speed of light, which takes about 40 milliseconds. If you were to go and like point this laser pointer somehow and aim it right, it would take 40 milliseconds for that pointer to go across the whole US. But nothing is right. The best case scenario when you're talking about switching delays and things not actually running in a straight line, 88 milliseconds. And that's actually an eternity when you're talking about trying to respond to something on someone's mobile phone, right? Like if you hit a button, or that, after 100 milliseconds, people stop. Like that, people think that something's wrong after 100 milliseconds. So that causes a lot of problems. So let's look at a scenario. Let's say we have Postgres as our primary database, and we have a cache in Redis, and it's on the East Coast, and we're talking to someone in Boston. That's still bad, even though you have a cache involved here, right? Like that actually doesn't help you any. Now, if you have a cache in both the East Coast and the West Coast, that person in Boston can hit the one on the East Coast, and they'll be very happy with the results. But there's a problem. You could end up in situations where someone might be routed to the, instead of the East Coast cache, to the West Coast cache for whatever reason, right? And then they actually might get different data. The key problem with this is thinking about someone with like a shopping cart and an e-commerce application. You put something in the cart, you're shopping around, and then all of a sudden it's gone from the cart. What's going on, right? So when you're caching, to have a mechanism that can actually do that for you, there's something in Redis Enterprise that does it. It's called CRDTs and active-active Redis. So in this way, you still have one centralized database. You have Postgres, and you could then, when you make an update to one peer cluster, one on, let's say, the East Coast and one on the West Coast, they'll automatically synchronize with each other and they won't lose data because they use a synchronization protocol called conflict-free replicated data types, which allows you to serialize all the different data that comes into it and resolve it in a way without you having to resolve that yourself in the application layer. It's really handy, and when you're talking about it from a caching perspective, if we were to go and do this exact pattern that we showed today, you would have synchronized caches coast to coast, right? So it's actually kind of useful. So that was my bonus section in case I was early and we're right on time. So next steps. We did this, photo shoot, and they're like, hold something and point to it. And this is what came out of it, and it's one of my favorite pictures of myself, even though it's ridiculous. Next steps, though. Whoops. You can get the module. It's available on NPM, Slonik Redis Cache. Slonik is also available on NPM. It's available on GitHub if you want to look at the code. It's not complicated. The demo is also available on GitHub, pretty simply. My GitHub and Twitter is Stockholm UX, which is a really long story which I won't get into. I need to change. You can follow me on those. And if you want to, you should subscribe to my newsletter called Redis Watch. Be one of 20,000 people that probably put it into their trash folder every month. But we actually do a theme every week, every month rather, and it's an entertaining read. I don't give you a dry newsletter. So now we have about 5 minutes for questions. Anybody have any questions? No? Okay. Well, if there are no questions, I'll stick around up here for a bit, and if anybody has any questions, you can come on up here. I know it was the last session of the day. I left Nashville at what would have been 4 a.m. West Coast time, so I'm going to go to bed after this. But if you can catch me in the next few minutes before I find a corner and curl up in a ball, come up and ask me questions. Thanks, everybody.